All right, thanks everyone. We're here today to discuss some Owens Corning products and capabilities, OC, HP, and PINKTANK, which are really designed to help the composites industry reach higher levels of performance through improved materials and design. My name is Patrick Haller. I'm a product director in our glass reinforcements business, and I'm here today with Dr. Amol Vaidya, who's an S&T director in our S&T center.
Thank you, Patrick. Pleasure to have this joint presentation with you. Thanks everybody for joining. We look forward to the conversation. Off to you, Patrick.
Yeah. So looking at the agenda, first today we'll talk about how we're changing the game. We'll talk through the materials and how they matter, talk about some specific higher performance composites and their applications, and then talk through our PINKTANK and how that helps with conversion and design support. I'll start with a video.
Every so often, an innovation comes along to create a big difference. Owens Corning's higher performance composites are that type of game changer. Higher performance composites enable weight, strength, and stiffness improvements, leading to globe-shifting outcomes. It makes you wonder, when else could a slight difference have changed history? What if the Leaning Tower of Pisa was built on sturdier soil? What if Venus de Milo was carved from something stronger? Or if cricket players swung a lighter bat? Would you look at that? What if Galileo's telescope allowed him to see farther? While we'll never know how history might have changed, we do know that higher performance composites can impact everyone's future. Together, let's make your game changer.
Okay, and I think that's really one of the key themes that we wanted to talk about today, which is that the material matters. So especially when we're thinking about composites, which are by definition two materials that are combined and enable us to capture the best properties of both. It's one of the things that I think we sometimes forget about in the composites industry, which is that we can really unlock the power of combined materials by improving either one of those materials or the way that they're designed. So there are quite a few examples here of all the different applications that composites have added value in various spaces. And I think the key unifying theme here really is that you take two good materials, and when you combine them, you can get great performance, whether it's a pipe or a truck panel or a structural part or a boat hull or an automotive part. Composites can really be valuable across the board. And the better that you make the material inside the composite, the better the composite performance is itself. When we talk about higher performance composites at Owens Corning, what we're really talking about is a next generation set of glass materials and products that can help take any application to the next level. So you can see here some examples across the single and roving landscape where there is value in using a higher performance material. So in pultrusion, for example, when you add a higher modulus, higher strength glass into a pultruded part, you can actually get the same performance, but make the part lighter at the same time, and even capture productivity benefits because you're using less materials. So for example, with our OCHP products, you can actually make parts that are 8% lighter. As another example, if you look in the rebar application space, you can increase the modulus of the rebar itself and even reach 70 gigapascals in structural applications, which is a step change for the industry and allows the use of GFRP rebar in new applications. Another example is in long fiber thermoplastics. When you put better materials, stronger glass into a long fiber thermoplastic part, you can make the part thinner and smaller, still get the same mechanical properties and reduce weight. And of course, when it comes to the vehicle space, for example, where many long fiber thermoplastic parts are used, those weight savings actually translate into fuel efficiency and many other benefits for the overall part design as well. So I think for me, that's probably the most exciting part about being able to bring these products to market from Owens Corning, is that they drive benefits in so many different applications in so many different ways just by starting with a better material. So that's only half the story though, which is where it gets even more exciting, because you can take a traditional ECR glass like Advantex, convert it to OCHP, and you get higher performance in application. But you can really unlock the power of composites when you combine it with design optimization. So utilizing better materials and design benefits to make even lighter weight and more productive and higher performing materials. I'll pass it off to Amol to talk a little bit about our PINKTANK capabilities.
Thank you, Patrick, for kicking the thing off. I think something that Patrick said, right, it resonates very well, is really a combination of what an advanced composite or a glass fiber can do, couple that with a design so that 1 + 1 is not equal to 2, but much more than that. So with that aspiration in mind, actually, Owens Corning has trademarked and launched a design capabilities under a name of PINKTANK, which is a registered trademark for the capabilities that we are going to talk about. It's, I mean, starting with the why, right? It's really a one-stop shop that is really leveraged for a couple of things, right? Either to optimize the end product or end application for you or for our customers. For example, leveraging the new advances in the glass industry or materials industry, how can we optimize it or bring a completely new material conversion to life? So in the next few slides, we'll have few examples of that, and then we'll take it from there. So what exactly is PINKTANK, right? So PINKTANK is a capability, which is a comprehensive resource or a one-stop shop where we can really model an application, be it in composites or in traditional materials. We can test the performance characteristics because it is very important to couple uh, modeling with the data, because a wrong input can lead to wrong output. So really testing or developing those material data cards that are so critical for composite performance prediction, and then towards the end really leverage testing to validate what sort of data would come out of that. And last but not the least, which is super critical for composites, is in terms of showcasing the cost performance benefit or value proposition of the end part, which may or may not be in composite, but how does it improve the performance of the part. So let's now look at what exactly are those capabilities that are enabling us to unlock the full potential. So as I mentioned previously, it is really a combination of design and testing, but data is a key word here. So in terms of the capabilities that we possess, really CAD tools, which are really how do we draw a part on a computer, meshing. For those who are design enthusiasts, modeling enthusiasts, understand that we need to mesh a part before it could be taken into any kind of analysis, be it finite volume or finite element analysis. uh, Micro and macro scale performance. So micro in a level of a single fiber, which can range from microns all the way to bundles, all the way to the macro or a part level performance modeling. Process modeling is a very interesting capability in which we are able to simulate or predict how the part performance will be if it is injection molded or compression molded part, and how does it connect with the new advances in terms of either glass chemistry or sizing or the resin chemistry. And last but not the least, the cost modeling or value proposition. How does it come together? Uh, so that's really the capabilities that we possess, but really coupled with that is a data, and that's where capabilities of material characterization at different levels and at different forms of material come in. So the capabilities that we possess include ASTM and ISO standards, but they also can expand to custom methods. For example, you see some of the pictures here, the different product forms in which we are able to perform those are either on a single fiber level or going all the way to a rebar or a composite pipe, or on the extreme right, wind in terms of static or fatigue. And all of these capabilities, be it mechanical or physical, thermal, or a connection with the microscopy. It really helping us to either on the beginning of design to generate the right material data cards, and towards the end to really validate in terms of what those are. And all of these are specific to composite ASTM standards. So I think it was an introduction up till now. Now wanted to share a couple of real life examples of how does it come together. So what you see on the screen here is a case study, and in this case is a process of thermoset pultrusion. So typically, if you look at any sort of design or modeling, you would envision on extreme left, which is a structural level part design. However, for composites, as we know, it is a complex system, but that's the beauty of it. So really starting at it on a extreme right top pictures, which is really what you're looking at is a cross section of a pultruded section. On the left hand side, or a black and white image, is actual SEM image, and on the right hand side is really how we are able to generate using modeling capabilities some micro scale models. Going to a level below that is a laminate level. So really playing around with OCHP, as Patrick talked about, what could be the performance benefits of that if we put in case of pultrusion a layer of CFM or continuous filament mat or veil, or different orientations. So really getting it all together is the philosophy that we use. So really looking at it from all angles, not just structural design, but have a material design into mind, having micromechanics into that thing as well. And the results are phenomenal, right? I think Patrick talked about what are the some of the benefits of these solid combination comes out. uh, Building up on that, this is an example of composite poles and cross arms, which is a key application that composites is growing into globally. So by replacing and optimizing the design from OC Advantex to OCHP, and optimizing the things like wall thickness as well as the shape and size, we have seen that for poles we can achieve around 8% higher tensile modulus increase by keeping the same profile, or if we optimize it by reducing the thickness, because now remember you're getting higher modulus, higher strength, so you are able to optimize your design. uh, so really translating into huge material savings, which are connected to not only reinforcement savings but resin savings as well. And connecting that to the cross arms, which in the picture they are seeing the horizontal sections on the poles, again translating the similar level of benefits up to 8.5% reduced deflections, because you are now increasing the stiffness. So really a very cool way to see how does it come together from materials and design combined together. Um, I have another case study, building upon that, and in this case, again, level of pultrusion or a process of pultrusion. But in this case, the key highlight here is leveraging the smart modeling capabilities. The results are very evident in terms of reduced time to market. And I think this is very critical. If you look outside, right, we have several challenges due to COVID. Getting skilled labors is shortage is a key thing for composite industry. And this is a time where if we leverage some digital tools, how we are able to expedite the new product, new application development. So in this specific case, we were able to deliver on a 15% weight reduction that translated also into cost reduction of around 13%, and without sacrificing the line speed and other performance characteristics. So speed is something that can be achieved if we have the right tools, if we leverage right products and right design. So so just to conclude, Ray, right? I mean, today Patrick and I we talked about how does a material and design combine together can help you to really take composites to the next level. So thank you, and we'll be happy to take any questions that you may
Yeah,
have.
yeah. Thanks, Amol. And it looks like we've got the chat moderated, but we've got a few questions coming through. So the first one that I think is interesting for us to answer is, what is the long-term future for glass and then modeling? And I can take the glass glass
Please.
portion first. And what excites me about our higher performance products as much as anything else is that we haven't yet reached the ceiling or the limit. If you look through the history of the composites industry, you can trace the evolution in materials and performance, and then even trace that through into the application space. The wind market, for example, which has been significantly enabled by improved glass reinforcements over the period of history. So I think the long-term future that I expect to see is a continued evolution of higher performance materials throughout the industry, enabling industry growth, enabling application development and conversion, enabling improved performance, and ultimately improving the lives of the end users. And so, so to me, the long-term future is long and the ceiling is high, and it'll continue to be a dynamic space moving forward. Amol, maybe you can comment a little bit on modeling.
Sure. Thanks, Patrick. So I think it's a very interesting question, right, in terms of composites and modeling together. Because if you look into traditional materials, modeling has been evolved over past several years. I think for composites, we are just starting up, and it's a fascinating journey that we are on. Simple example of material data cards, right? And connecting that with one of the questions, which is here in terms of material properties. I think if you go to any conference where we are talking about composite modeling, it always comes down to, do we have the right material data, right, that goes into it. So I think that's, from that perspective, we are just starting on things like development of material data cards, or connecting to the different methodologies of how to make a part. So likewise, Patrick, as you had mentioned, I think for composite modeling, we had just started on that journey, and it's a long and exciting journey that we are on.
Good. Okay, there's two other questions in the chat, and I think we probably have time to answer both. Amol, the first one's for you.
Yeah.
When it comes to working with PINKTANK, does optimization mean developing custom OC product formulations for the end use, or are solutions limited to finding the standard products that work best for the end use?
Mm-hmm. Yeah, there's a very good and a very practical question. So I would say sort of both, and it depends so much on the end application, right? So in terms of optimization, I'll go with have the second one, right? In terms of solutions, so it's not really limited to finding solutions in terms of standard product, but having non-standards, right? And an example here is, if you have a fabric construction of specific way, by optimizing, there could be possibilities or opportunities to really tweak it or go to the next non-standard product level. And then on the first one, in terms of custom product formulation, I think the custom word is quite interesting here, but I think the short answer here is it could be both. And optimization is really your material optimization, process optimization, and shape optimization. So really that encompass all these three things. Patrick, I don't know if you want to add anything around the standard product question part of the question here.
Yeah, I think probably the other comment there with regards to Owens Corning more broadly is that if there is an opportunity or a place where a custom product is needed, that's certainly something that we can help with, right? So we'll always start with the standard products. They're already there, and we have a very broad portfolio. But certainly if there's a specific need in the market, we've got our customer technical support organization who can work closely with our customers to try to find those opportunities and help meet our customer needs. The last question that I think we'll have time for here is, are there material improvements and what are the properties? So I can share a couple of the key properties right now for the OC HP glass, and really just at the simplest level, the Young's modulus of the glass is 89.5 GPa, and the fiber tensile strength is around 4,700 to 4,800 MPa. There's a full data table. If you click on the link at the top that says learn more about OCHP, that'll take you right to our product landing page where you can find full data sheets and additional information. Certainly feel free to reach out to myself or Amol at the email addresses listed below if additional details are needed. But you'll be able to find all the all the properties there on our website. So with that, thank you everyone for your time. It's been great.
Thank you very much for the opportunity and all the questions. Thanks.